Okay, now we're going to look at number 17, part A on the study guide. This may seem like complicated and unfamiliar, but you're going to get very familiar with this. It's going to appear really easy and trivial. I'm going to use my calculator as an aid to kind of build a strategy for me. So I'll put this function along with other similar versions. Soon you're going to be telling me these other two. You're going to recognize them really easily. Let's look at the graph of that thing. It actually takes your calculator a while to graph it. I'm actually in the Zoom trig window. Zoom, if you look at option 7, it's trig, so you can use that, but Zoom standard will work fine too. But since it's a trig function, Zoom trig is a little bit better. So you notice right at 0, it kind of seems to have a point there. Now, it's hard to see, so I'm going to zoom in by hitting zoom. Option 2 is zoom in. You can either go down to 2 and hit enter. I just like to fast forward. I just hit the number 2. And then you have to hit enter to actually make it zoom in, because it's like, well, where do you want to zoom in at? Do you want to zoom in at the origin, or if you hit up a couple times, it'll zoom, I'll let it point up. But you can zoom in anywhere. Really, it'd be a smarter idea to zoom in closer to the top, but it doesn't really matter. Just I want to make sure I can see, the value as x approaches 0, which you notice is going to be slightly less than 1. Okay, so let's see if we can find out exactly what it is at 0. Here's the problem. At 0, this function doesn't have a y value. I can go a little bit left of 0. The y value is 0.9 and some change. Alright, a little bit right of 0, still 0.9, so it's really close to 0.9, but let me get a little closer value by using a table. I hit second. I hit the graph button, because above the graph button is the word table there. So I'm going to go you go to 0.5, which is, I guess, kind of close to 0. You get that. Let me try 0. Again, error, because it's undefined at 0. How about 0.1? Go even closer. Let's do 0.01. Even closer, let's do 0.001. Even closer, let's do 0.0001. And that's it's saying 0.9, but really it's just 0.9. It's really close. Let's do a bunch of zeros, because it's really close to 0, and then hit a 1. So it actually puts it in fraction form, which I find kind of interesting. But so the limit, as you get close to 0, the value of this function gets really close to 9/10. Can you see where that 9/10 comes from? Well, it's really just the quotient of the coefficients. So without using your calculator, okay, notice how I have them in here, but they're not visible on the graph. Can you tell me what the limit for this one would be? So if you took the limit as x approaches 0 of sine of 3x over sine of 4x, well, I hope you said it was 3/4, because it is. Again, I'm going to go ahead and reveal this thing. Okay, it's going to start showing up on my graph and my table. You go to my table. If you notice, as I take those x values are really close to 0, you get 3/4 here. All right, what about the third one right here? Which I'll put them in y1, y3, and y5 just so they're easier to read, so there's more space between them. I'm going to go ahead and reveal this function by going over the equal sign and selecting it, and now it's going to show up in my table. Well, it'd just be whatever 6 over 12 is. What's 6 over 12? I hope you can see that's going to reduce to 1/2. So as I take values really close to 0, the limit approaches basically 1/2. So the idea is all it is just the quotient of your coefficients in front of the x there. And that's number 17, part A.